Hi, welcome back to this video series on program synthesis. In the previous segment, we talked about how to write a program, how to synthesize a program that will check whether two numbers x and y can be added safely. And today, I'm going to ask a different question. Can we do this safely? Can we do subtraction of x and y safely without creating overflow problems? For example, if you recall from the previous session, we had a 3-bit number as a demo. So we said, okay, this is the 3-bit representation, right? 1, 2, 3, and then -4, -3, -2, and -1, right? So let's take an example, x to be 3, right? X to be 3, and y to be, say, -4. Okay. So what is x minus y? X minus y in the regular arithmetic is 7. But if you remember 7 is 4 plus 2 plus 1. So it is basically 1, 1, 1, 4 plus 2, 6, 6 plus 1, 7, and a 0, right? But as you can see here, we have only 3-bit representation, right? We have only 3-bit. That means we throw away the most significant bit. Okay, so we throw away this most significant bit. Boom. So what is left is basically 1, 1, 1, which is nothing but -1. So it's weird that 3 minus -4, 3 minus -4 is actually 1, is actually -1. Okay, that makes sense. If you start from 3 and add 4 steps, 1, 2, 3, 4, you're ending up with -1. Okay, so here is an example where we were able to subtract two numbers, and usually if you subtract x and y, we get in regular arithmetic we would have gotten 7 as the answer, but here we are getting -1. This is basically a problematic subtraction, that we cannot safely subtract these two numbers without creating an overflow. Okay, so the goal is to write a program that will tell us when is it safe to add or when it is safe to subtract, in this case, two numbers x and y. So I'm not going to write a program per se. I'm going to synthesize this program using program synthesizer. So I'm going to show you how I synthesize this program. Okay, so let's get it going now. So what you're going to see is this program called 2's complement subtraction OK detector, right? So what I'm going to do is I'm going to leverage whatever we already synthesized, right? We already synthesized a program that will help us to check whether two numbers can be added safely, right? We already used that program. Using program synthesizer, we already, in fact, synthesize it. So why not just use that whole function that was synthesized from the previous session? And I'm just adding that grammar, that function name to the grammar. Here is it, right? So I'm going to synthesize a subtraction, okay? Because our instincts must telling us that if we know how to check whether two numbers can be added without getting into overflow, we should be somehow be able to use that program for subtraction detection as well, right? So that's basically my instinct to put that. And then we already synthesized the same sign also. We did a session on that. It checks whether two numbers x and y are same sign, both positive, both negative, and so on. So now I'm going to just run the synthesizer on this grammar, right? To synthesize a program for me. First, I will show you a scenario where I didn't do examples. Okay, in the past videos, I did examples to synthesize a program. Here, I'm going to do more a formal specification. Okay, so what is the meaning of the formal specification in this case? So I'm going to specify more precisely when do we say two numbers can be subtracted safely. Okay, there are two possibilities, right? If both numbers are, say, let's consider this scenario. If the number x is less than 0, okay, and the number y is greater than or equal to 0. So this scenario is this, right? Your x is less than 0, and your y is greater than or equal to 0. Okay. So now you're checking what is the signature of x minus y. What is the sign of x minus y? So if there is no overflow, x minus y will also be negative, right? If there is no overflow. But if there is overflow, we know for sure this is going to be greater than or equal to 0. In that case, we say this is overflow. Yeah, this is an overflow. Similarly, we do the positive overflow. We take x to be negative number. Here is the x to be negative number, right? We did that part. Let's consider the next part. Okay, so let's consider this part now. Positive overflow. Okay, what it means is that your x is greater than or equal to 0, and your y is less than 0. So what are we now doing? We are going to do x minus y. Okay, so now let's answer about this. We have a number x greater than or equal to 0, and we are subtracting it by y, which is also less than 0. So that means basically we are adding two numbers x and y, right? Forgetting about the sign. Okay, if there is no overflow, what do we expect this to be positive? Otherwise, if there's overflow, it will be negative. Okay, that's the reason we are checking whether this is true. If this is true, then we say, yeah, there is a positive overflow. So these are the two overflow conditions, right? So when do we now can safely subtract x from y, or y from x rather? So we can subtract x minus y if there is no positive overflow or no negative overflow, right? So we don't want, that's the reason we are saying here, you don't want negative overflow nor positive overflow. That's basically the whole constraint, okay? So we want a program that satisfies these constraints. However, you might say, well, your specification itself is a program. That's true, but here is an if then else statement, right? And I'm going to synthesize something without an if then else statement using the constructions that I have put inside my grammar, okay? So first I will just quickly show you the grammar, which is exactly the same as what we saw earlier. We now added the 2's complement addition function that we synthesized earlier. Okay, so let's see whether we can synthesize this very quickly. Okay, it was extremely quick. In a few seconds, okay, we got this synthesis program. Okay, what is it really? It is basically a program that tells us whether function f, this is basically the t sub okay function, right? It takes two numbers x and y, and it tells us whether these numbers can be subtracted. Okay, x minus y can be performed or not, based on this really nice idea that all you have to do is you call the add functions that you already synthesized, right? And you check whether t add okay returns true or not. That's it, on the arguments of y and not x. Okay, we already synthesized this in the previous video, so we can just use this function to decide whether x minus y can be performed without any overflow. Okay, this is basically it. Okay, I think this is a very nice way to synthesize logical, small, tricky problems that are not necessarily easy for humans to come up with. Okay, so one thing you may question me is that I have given a formal specification. Of course, it's very powerful that I have proved it that these two things are same. But what if you don't like the formal specification idea? Okay, that's perfectly fine. In that case, I will show you what you can do. Okay, that's basically what I'm going to do is take the idea of example, right? Learning by example. So I have written a copy of this program just to demonstrate to you that if you don't like formal specification, that's perfectly fine. You can just train it with, you can throw away the formal specification, right? All of these things can go away. You can just use examples like this, right? These are the examples. Okay, so I'm going to very quickly do this, right? I want this for my experiment, so I'll keep it. So what I'm going to do though is I will just get rid of my my formal specification just to show you. You can also learn by example if you don't like formal specification. Okay? But you have to be careful that your examples are good, having good coverage, right? Otherwise, your synthesis is not perfect. You're not able to synthesize it and generalize it. Okay, so here are the bunch of examples, and now we are going to synthesize a program based on the example. Okay. Okay, so this is clearly wrong, right? Subtraction doesn't satisfy. Oh, this is specification. So we can delete this because we remove the specification. So now let's run this. This is no formal specification, just learning from example. Okay, right away we synthesize exactly the same program that we already saw, right? Remember, this is very, very similar to what we synthesized earlier. They both are same. Okay, the only difference is one uses a formal specification, another is learning by example. Other than that, no difference. Okay, so what we learned today is that we are able to formally synthesize a program that will help us to answer this question: can X and Y subtraction be performed without creating overflow or underflow problem? The answer is yes. The computer can synthesize such a program for us. Okay, that's what we have confirmed. That's basically what I wanted to show to you. Thank you for your attention.